Hello everyone, my name is Seth Ford and this is my final project submission for IST402. For my project, I decided to create a prototype search and rescue robot. It's going to be tasked with driving this little course I've set up, which is just my living room, and recording all the shapes it finds. In addition, when it sees a triangle, it's going to create an alarm sound. I'll give you a little tour of the robot here too. Up front we have a camera. Down below there's an ultrasonic module, which is essentially echolocation. There's a line following module. A Raspberry Pi is mounted right here in the middle. On top is the robot hat. There's a battery pack in the middle. And below I've mounted my own little breadboard for a buzzer. There's supposed to be a buzzer on the robot hat, but for some reason I couldn't get it working. For my 5 main goals, the first was to have remote control of the robot. This was accomplished by creating an if-else loop. The user is asked, or when the user presses a key, either W, A, S, or D, the robot is told to move forward, move backwards, turn left, or turn right. If no key is being pressed at all, which is my final else at the below here, it tells the robot to turn the wheels forward and to shut the motors off. When I was trying to design this, I ran into a problem that the default program, the tutorial that comes with the robot pack, wasn't working. So I had to design my own, and this is what I came up with. When you press escape, it shuts off the program and exits the simulation. My second goal was to have a wireless video feed. So as you can tell off the bat, it already is wireless. There's no wires going to the computer here. And this is a remote desktop session. I used Microsoft Remote Desktop, and this is the Canvas page on my home computer, and this is the remote session. From here I can control everything on the robot. My camera is screwing with me a little bit. There we go. So I'm going to now set up a live video feed. I'll turn the robot on. And in the left-hand window, you can see a live video feed. If I go over there and wave my hand a little bit, you should see it. It is a little choppy, but for this project, I think Microsoft Remote Desktop worked just fine. The third goal I wanted to accomplish was automatically differentiating shapes. As you can see on the screen here, he has square highlighted. I could have used a program and software like TensorFlow, but it seemed a bit complicated, and for the time limits of this project, I didn't want to spend a whole lot of time on something I wasn't familiar with. So instead, I used a masking technique, which finds shapes by their color. So on the left here, you can see my regular video stream. And on the right, you can see the mask. A mask can be imagined as a filter controlling what information the brain of my robot sees. So it's not actually limiting the vision of my robot. It's only limiting what calculations can be done on what it's seeing. My fourth goal was to count and record all the shapes in a report that can be viewed afterwards. This created a few problems. The first, how can I tell the robot, or how can the robot tell the difference between one shape to the next? For example, as it drives around the course, it may see more than one square. How can it tell the difference between the two? Furthermore, how can it tell the difference between this square it's seeing now and that very same square 5 seconds later? What's to prevent it from reporting the same square over and over and over again? To fix this problem, I created two types of counters. The first is called a general thought counter, and the second is called a shape thought counter. You can see both of them running here. The general thought counter is always running, even when Alfie, the robot's name, isn't looking for a shape. This creates a time window of roughly 15 seconds through which the robot can identify a shape. This way, the robot has enough time to drive away and go look for a new shape before trying to report the same shape again. The way I had it tell the difference between this same square and the same square 5 seconds later was by using shape thought. Shape thought is the second number there at the bottom. It's not labeled. It's right under the line that says it's a square. You can see it counting upwards. And as it hits 100, it says, I'm sure it's a square, and it adds this number of squares it's seen so far to the report. When Alfie first sees a shape, he's going to count the number of sides and store that as a variable. From there, he kicks off the shape thought counter. As the shape thought counter is increasing, he recounts the number of sides over and over again. If at any point during this verification process he counts a different number of sides than what he originally counted, he will restart completely from scratch. However, as you can see here, if during that verification process both counters reach their conclusion, right there, he will verify that the shape is indeed what he thought it was and add it to the report. I created a diagram to help make that easier if that was confusing. The robot first starts looking for a shape. Once a shape has been found, it starts the shape thought counter. It then counts the number of sides of the shape it sees and stores it as a variable. It counts the number of sides multiple times. If at any point the count is different than the variable it stored, it restarts. Otherwise, it verifies the shape. My fifth and final goal was to sound an alarm when the robot sees a triangle. This is to simulate the target during the search and rescue, whether it be a person, an item, or something else that the robot should alert the humans at the scene to come and take a look. That is better shown during the actual demonstration of the robot, which I will start now. First, though, I need to delete the report file that was created after, see, he's added like 32 squares. I don't want that part of our simulation, so I'm going to exit out. Here's my shape report. I'm going to delete that. And we are good to go. All right. So he's already on the course. He's going to start identifying this square. He has confirmed it's a square. So now I'm going to have him drive away. You can see him here. Now he's looking at the pentagon. He confirmed it's a pentagon. So now I'm going to have him drive away. Go towards our next shape. I got a little too close here. Maybe if I back up a little bit. You see, here's a good example of he's not sure if it's a pentagon or a hexagon. He's constantly flipping back and forth between the two. And you'll see the shape thought counter is constantly resetting. That's preventing him from adding this incorrect shape to the report. Let's see if I can get a good angle on this. Ooh, there's a good look. Hexagon, hexagon, hexagon. See if I can get him to... Well, he's still not entirely sure. What I can try doing here is altering the mask. These bars up here, as you see as I move them, alters what the computer can see. So I manipulate this a little bit. It's not really working. Maybe if I bring this one up. He doesn't want to do this hexagon. We'll continue with our search. He's driving around, making this corner. Trying to do the triangle now. And there's our alarm. All right, now he's going to continue on his search. Let me fix the windows here. Got a square. Great, he just confirmed that one. Uh-oh. He's not liking pentagons right now. Why the hexagon? It's possible the lighting changed in the room between my test run and when I shot this final video. Ooh. There you go. Now he's sure it's a pentagon. And that's all our shapes. So now I can go into my report. And let's just do some verification here. So I got one square, one pentagon, one hexagon, one triangle. We got two squares, two pentagons. So he couldn't identify that hexagon in this run for some reason. I'm not sure why that happened. But let's open the shape report. And we can see one triangle, two squares, two pentagons, and the hexagon that he missed. And that's just about it. Thank you guys for watching.